Welcome to the 12th episode of the Grand Cosmic Story. Have you ever wondered how these beautiful life forms came into existence? What is the mechanism by which the first life started? Did it start from vents on the seafloor or did it descend from space? How did our chemistry give rise to biology?
Are you curious about the world around you? Do you wonder what else is out there beyond our world? Dr. Latha Christie, a scientist and an author, will take you on a journey through the universe. Join her in exploring the universe through her web series, The Grand Cosmic Story. Stay tuned to find out what today's episode is all about.
The question of how life began is one of the most profound questions in science. It's perhaps the most fundamental and at the same time the least understood biological problem. Understanding life's origin would help us grasp our place in the universe and guide our search for extraterrestrial life. Although many theories exist about the naturalistic origin of life or abiogenesis or life from non-life, scientists still cannot agree on an answer. It continues to be a topic for debate. The first exciting idea that captured a few scientists' attention was the primordial soup theory, the notion that when Earth was young, in a reducing atmosphere of methane, ammonia, and hydrogen, natural energy sources such as lightning could have produced the first chemical building blocks of life. Such building blocks could have dissolved in the ocean to form a primordial soup from which the first living cells could have emerged. Later, these would have eventually self-assembled into simple living cells, and this idea was proposed in the 1920s by two researchers working independently, Russian scientist Alexander Oparin and British scientist J.B.S. Haldane. Taking this idea forward, University of Chicago graduate student Stanley Miller announced in 1953 that in the laboratory of his PhD advisor Harold Urey, he could experimentally show that lightning in the Earth's primitive atmosphere produced amino acids, the chemical building blocks of proteins. For this experiment, Miller used a closed glass apparatus in which he boiled water and then circulated the steam with a mixture of methane, ammonia, and hydrogen that would resemble Earth's early atmosphere and generated electric sparks to model lightning. His experimental result was widely advertised as the demonstration of the first step in the origin of life, as he could detect some of the amino acids that are found in living cells when he analyzed the brown tarry mixture collected at the bottom of his apparatus. Though Miller and Urey's model showed a lot of promise initially, biologists soon found that the experiment did not produce the amino acids needed for life and thus could not demonstrate the origin of life. The reasons for the failure to produce life-giving amino acids are: number one, the significant outcome of the experimental mixture was toxic, which is capable of damaging the DNA. Number two, the atmospheric condition used by Miller and Urey was radically different from the early Earth's atmospheric condition. It was found by many geochemists that the Earth's early atmosphere not only consisted of a reducing atmosphere but also consisted of neutral gases and enough oxygen to destroy all the amino acids in the atmosphere. Number three, Miller and Urey used a chemical trap that was not present in the actual scenario. He used the trap to remove the newly formed chemicals before the next spark. If there is no trap, the chemicals or building blocks would have destroyed due to reversible chemical reactions. Number 4, the experiment produced only a very few amino acids found in living organisms, whereas a single protein requires a chain made of more than 50 amino acids. The absence, addition, or replacement of a single amino acid in the structure of a protein causes the protein to become a useless molecular heap. Number 5. Miller's experiment could not produce the right amino acids with the preferred handedness needed for life. One of the strangest aspects of all life on Earth is a mysterious phenomenon known as homochirality, which puzzles chemists, biologists, and theoretical physicists. Each of life's molecular building blocks, that is, amino acids and sugars, has a twin. Not an identical one, but a mirror image. All sugars in DNA and RNA are always right-handed, whereas all amino acids in proteins are always left-handed. Our feet or our hands are non-superimposable mirror images of each other. We cannot superimpose all features of one foot or hand over the other. A right-handed glove will never fit comfortably into a left-handed glove. Life on Earth is made of left-handed amino acids almost exclusively, which is puzzling. The Miller and Urey experiment could produce only a mixture of 50% left, 50% right-handed amino acids that cannot give rise to life. Number 6. The discovery of the elegant double helix structure of DNA by James Watson and Francis Crick revealed that such a complex, self-replicating, information-carrying, immensely complex molecule would not have spontaneously come from inorganic compounds, putting an end to the primordial soup theory. 2 years after Crick found that DNA is a double-stranded molecule that twists around each other like a spiral staircase, he proposed the sequence hypothesis, which has become part of the central dogma of molecular biology. According to the sequence hypothesis, information on the DNA molecule is stored in the form of 4 specifically arranged chemicals called nucleotides along the spine of DNA's helical strands, represented by the letters A, T, G, and C for adenine, thymine, guanine, and cytosine. Soon, a series of brilliant experiments confirmed DNA's information-bearing properties, that every cell in our body has an exact copy of us in the form of DNA, averaging around 3.1 billion bits of data. Let's suppose that we uncoil the DNA inside one of our cells and stretch it. It would stretch to roughly 2 meters when stretched end to end. Now, if we uncoil the strands of all our DNA and place them end to end, we would get a 67 billion miles long strand that would be equivalent to about 150,000 round trips to the moon. Now, if you look at the nucleus of a human cell, which contains the DNA, it's only about 6 micrometer in diameter. Now imagine packing such a lengthy strand inside the nucleus of a cell. That means the packing is very tight, amounting to packing 40 kilometers of extremely fine thread into a tennis ball. This is accomplished by wrapping the DNA around proteins called histones, and the protein partners help package it into a tiny space. The complexity of DNA is highly sophisticated and ordered, transcending the realm of science into the realm of miraculous. That is the very reason that many scientists are in agreement that such complexity could not have spontaneously come from the primordial soup. Today, Miller and Urey's experiment that suggested that the first life came on this planet from inorganic matter is totally disregarded by all scientists. The second great idea for the origin of life from non-life is the hydrothermal vent theory, which says that the first life arose in the deep sea hydrothermal porous vents that pour out hydrogen-rich molecules. However, many scientists disagree with this marine origin theory, since the same process of protein cell formation should happen even today in those vents. But we are not able to observe it. Also, marine environments are far too rich in sodium, but for cells to synthesize protein, they need a lot of potassium and not sodium, as sodium blocks these activities. Finally, Fred Hoyle and Chandra Wickramasinghe proposed another great idea called the panspermia theory that suggests that life would have started on some other planet other than Earth and would have been brought here through meteorites or asteroids. However, the search for intelligent life elsewhere in the universe beyond Earth is futile. Even if there is life elsewhere, they would not have hitched a ride to Earth and survived the harsh space environment. Many scientists are critical of the panspermia hypothesis because instead of answering the question of how life first originated, it passes the question of the origin of life to another place in space. Let us suppose that we have got the first amino acid somehow. Now, is it possible to create a cell? Creating a cell is an impossibility, as even the elementary type of cell constitutes an unimaginably complex mechanism. Take the example of a simple protein molecule which is composed of 288 amino acids of 12 different types. It can be arranged in 10 power 300 different ways or one followed by 300 zeros. Of all these possible sequences, only one forms the desired protein molecule. The rest of them are amino acid chains that are totally useless. In other words, the probability of the formation of one protein molecule is 1 in 10 power 300. There are many giant protein molecules consisting of thousands of amino acids. Even the smallest bacteria ever discovered contains 600 types of proteins. Now apply the probability calculations. You will get the word impossible. Also, biologists who work on the origin of life face a chicken and egg problem. During the cell division, DNA duplication requires proteins. While proteins are needed for DNA synthesis, DNA is needed for protein synthesis, and this creates the chicken and egg problems. That is why the astronomer Fred Hoyle made a comparison and stated that the chance that higher life forms might have emerged in this way is comparable to the chance that a tornado sweeping through a junkyard might assemble a Boeing 247 from the materials therein. Chandra Wickramasinghe comments, the likelihood of the spontaneous formation of life from inanimate matter is 1 to a number with 40,000 zeros after it. It's big enough to bury Darwin and the whole theory of evolution. Francis Crick finally writes, an honest man, armed with all the knowledge available to us now, could only state that in some sense the origin of life appears at the moment to be almost a miracle. For many investigators, the origin of life is a mystery and baffling. Einstein once said the most incomprehensible thing about the world is that it is comprehensible. The fossil record shows that the major groups of plants appeared suddenly and fully formed around 400 million years ago. The gymnosperms and plants like conifers, ginkgo and cycads that had an adaptive advantage of dominating the forest during that period. The first fossils of vascular plants were seen 375 million years ago. The flowering plants appeared in the fossil record fully developed, and the fossils show no evidence of changes that might have occurred in developing from the lower forms to the flowering plants. There are no known ancestors for a majority of the major phyla of plants. The creation of plants helped in removal of carbon dioxide from the air, replacing it with oxygen. The early earth contained only 5 to 10% oxygen. Plants, algae and bacteria help to increase the oxygen percentage in the air by simultaneously increasing the percentage of oxygen in the Earth's atmosphere and decreasing the percentage of carbon dioxide. Plants paved the way for the rise of land animals. The sequence of the creation process is perplexing. It's rational to think that only an intelligent designer could have orchestrated such a creation sequence, creating plants of various varieties, thus planning for a beautiful landscape we see around us. The magnificence and the beauty of the world around us make us wonder how is special? Let me ask you, what do you think is more plausible? Can a tiny little life wake up suddenly and come alive deep under the ocean in a special spot on a little pale blue dot in the vast cosmos? Or are the beautiful life forms we see around us are specially created out of an act of great love?
Then God said, "Let the earth bring forth grass, the herb that yields seed, and the fruit tree that yields fruit according to its kind, whose seed is in itself on the earth." And it was so. And the earth brought forth grass, the herb that yields seed according to its kind, and the tree that yields fruit, whose seed is in itself according to its kind. And God saw that it was good.
Bye for now. See you again in the next episode. Let's explore together if there can be a design without a designer.